Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on June 26, 2025, about a week ago. This paper shows that even when LLMs can correctly define a concept over 94% of the time, they often fail to apply it correctly more than half the time. The paper is titled Potemkin Understanding in Large Language Models 2506.21521v2. And it suggests that our standard benchmarks might be giving us a false sense of security. The authors introduced the idea of Potemkin understanding, an illusion of comprehension where models give answers that are inconsistent with human-like reasoning. So to illustrate this, the authors provide a great example using what they call a keystone set, which is a minimal set of questions meant to test understanding. First, they ask GPT-4o to define an ABAB rhyming scheme, and it does so perfectly. But then, when asked to apply that rule to a poem, it fails. It provides a word that doesn't rhyme. This failure is the Potemkin moment. What's really striking is that when they then ask if the words rhyme, the model correctly says no, showing a deep inconsistency. This next figure really clarifies the formal framework. You see these grids where rows are different interpretations of a concept, and columns are questions. Green means a correct answer. Red means incorrect. For humans, answering a specific keystone question correctly, like question 3 on the left, proves you understand the concept. But the LLM interpretation at the bottom gets that keystone question right, while still having an overall incorrect understanding. That's the Potemkin. The right panel just shows that sometimes you need multiple questions together to form that keystone. Okay, so this table quantifies just how widespread this problem is across different models. It shows the Potemkin rate, which is the percentage of times a model fails to apply a concept after it has already defined it correctly. And you can see across different tasks, like classifying examples, generating new ones, or editing, the failure rates are significant. Looking at the overall results, models fail to apply concepts they can define correctly between 40 and 55% of the time. This problem isn't isolated. It's consistent across the board, from Llama 3.3 to GPT-4o. So to probe these failures more deeply, the authors designed an automated test for what they call incoherence. This diagram illustrates the method. First, they ask a model to generate an example of a concept, like a slant rhyme, and it gives time and mine. Then, in a separate prompt, they ask that same model if the example it just created is correct. If the model says no, it's contradicting itself. This self-contradiction shows a deep internal incoherence, and it gives researchers a powerful, automated way to find these Potemkin moments. And this table shows the results from that automated procedure across a range of models. The first column is the incoherence score, where 0 means perfect performance and 1 is essentially random. You can see some models like GPT-4o and Claude 3.5 have very high incoherence. They contradict themselves a lot. The second column shows the Potemkin rate, and even though this method provides a lower bound, the overall rate is a striking 0.62. This suggests that, on average, the models are failing to correctly apply concepts they seem to know over 60% of the time. So, what's the big picture here? The key takeaway is that this Potemkin understanding, this illusion of comprehension, is a pervasive issue. Models can define concepts almost perfectly, but then fail to apply them more than half the time, and often contradict themselves. The crucial conclusion from all this is that our current benchmarks, which are often designed around human patterns of learning, just aren't reliable for measuring true conceptual grasp in LLMs. This is a fundamental challenge for the field. That's all for today's AI Research Roundup. Thanks for tuning in.